Hey YouTube, how's it going? YakScience here with another biology video, and today we're going to be talking about water. We all know that water is one of the most important compounds for life. We know that it's one of the most abundant compounds on Earth, and today I wanted to basically focus on the general structure of water and how that structure gives it some really unique properties. So here I've drawn the basic structure of a water molecule. Notice that it's just two hydrogen atoms covalently bonded to an oxygen atom. Also note that the shape of it is bent, kind of like a V, and that's because of the electron distribution. But for now, don't worry about that. What I really want you to take away from this is that water is a polar molecule. What do we mean by that? We know that oxygen is more electronegative or electron pulling than hydrogen is. And so that means that the oxygen atom here will pull the electrons towards it, giving it a partial negative charge. Not a full charge, a partial negative charge. That in turn will give each of the hydrogens a partial positive or delta positive charge. And that's what we mean when we say water is a polar molecule. So it turns out that this polarity is what's going to give water the ability to have all these really cool and unique properties. The first property I want to talk about is cohesion, which is essentially the idea that water molecules like to stick to one another. Now we can see why water molecules love sticking together so much because of this polarity. Notice the hydrogen here has a delta plus charge. Imagine we put a second water molecule close by, this time with the oxygen, which is partially negative, close to the partially positive hydrogen of another water molecule, right? So when we do that, we can see, wow, there's an attraction here between a partial positive charge and a partial negative charge. This attraction is called a hydrogen bond. It's not exactly the strongest bond, but it is strong when you have these in large quantities. And so from this, we could see why water has this cohesive nature to it, why water molecules love to stick together. It's because if they orient correctly, where delta positives and delta negatives are close to one another, they stabilize one another's charges, and they're attracted to each other essentially. And because of this cohesion, water has a very high surface tension. We know that there are insects and even I think one type of lizard that can walk on water, and that's because water has a high surface tension attributed to its cohesive nature. And in turn, that cohesive nature again goes back to water's ability to hydrogen bond. So next I want to talk about capillary action. Capillary action is seen when water essentially shoots up a capillary or a thin tube, right? So let me draw one. All right, so here's a capillary tube, and we see that the water rises up the tube and forms a meniscus right over here. Now the reason it's able to rise up, two reasons. First of all, cohesion, which we just talked about, means that the water molecules that are higher up are going to pull the water molecules below it, thus pulling all of the water upwards. But a second factor that contributes to it is adhesion, which is the property of a liquid like water sticking to a non-water substance like glass, okay, because of any partial charges or full charges found within the glass. Okay, so a combination of cohesion and adhesion allows water to move up capillaries. And that's super important in nature, right? Think about the xylem in plants. Xylem is a microscopically small or thin capillary, essentially, in plants that allows water to shoot up the plant and get delivered to different parts of the plant's tissues. So next I want to talk about water as a solvent. A lot of people call water the universal solvent, but you got to be a little careful with that wording because water can't dissolve everything. Let's see what we mean by that. So if we take some NaCl or sodium chloride and we drop it into a bucket of water, what's going to happen? What's going to happen is the water is going to dissolve the NaCl by breaking the NaCl into its component ions, Na plus and Cl minus. And that's favorable because just like we said before, water is polar. And so the delta positive hydrogens on water can form interactions with the negatively charged chloride ion, while the partially negative oxygen atoms in water can form interactions with the positively charged Na plus ion, right? So we see here that when it comes to the Na plus, it's very favorable for the water's oxygen atoms to surround it because they are delta minus, whereas with the Cl minus ion, it's very favorable for the water's delta positive hydrogens to surround it. So this is what we mean when we say water is dissolving a substance. It's essentially forming hydration shells around its charged components. Now we said that water can't dissolve everything, So we know that if we stuck a hydrophobic or non-polar substance into a bucket of water, like oil for instance, water wouldn't form those hydration shells around the non-polar substance because there would be no significant interactions to be made, right? And so that's why you would get two distinct layers, one oil layer and one water layer. But when it comes to charged substances, they're usually pretty dissolvable in water. Next, I want to talk about the specific heat of water. When we say that water has a really high specific heat, we're saying that it takes a lot of energy to increase the temperature of let's say, a bucket of water, right? It takes a lot of energy to change the temperature of water. And that, just like all the other properties, is attributed to hydrogen bonding. So how is hydrogen bonding related to having a high specific heat? Well, when you try to heat up water or cool down water, a lot of the energy associated with those processes goes into breaking and forming all of these hydrogen bonds. And so you get a small change in temperature. And that's why cities that are surrounded by water, like coastal cities like Los Angeles, have really moderate temperatures. It's because on really, really hot days, the surrounding water will absorb a lot of that heat. And on really, really cold days, the surrounding water will release heat. It's almost like water serves as a heat sink. So water has a very high specific heat capacity. And finally, I want to talk about the density of water. Unlike most liquids, water actually becomes less dense in the solid form compared to the liquid form. And that's because when water freezes, it forms this really intricate crystalline structure that sets the water molecules further apart from one another than they would be on average in the liquid form. And since the water molecules are frozen further apart from each other, you get solid water being less dense than liquid water. So if water didn't have that property and behaved like most other substances, all of the oceans and bodies of water would essentially freeze because ice on the top would sink to the bottom and then freeze the water above it, right? So thankfully, only the surfaces of water typically tend to freeze, thus insulating the water below it. So that's an intro to water and its properties. I hope that was helpful, and thanks for watching.